We'll start with today's lecture. So we have already talked about fault collapsing. So we saw how we could see equivalence between any two faults for simple AND gate and NOR gate. Let's continue with that. So before I consider that circuit, we'll first see this equivalence there. So let's say we consider simple OR gate. Before that, for AND gate, I'll just again, it will be a revision for you, as well as it will be listed here. So these are the two possible faults. So in all, we have 6 possible faults. Okay. But I know that if any of the input is 1, it means any of the input is 0, it means my output is also going to be 0. So I can have equivalence between this. And since even if single output is 1, then also it will be 0. So I can have equivalence between these two. So it means I have equivalence achieved between this stuck at 0 and this stuck at 0 and this and this. So out of these 3, I need only 1. So I can cross any 2 and I need 1. So number of faults, minimum faults that I need to consider is 4 only. Similarly, we had talked about your OR gate. Again, possible faults, stuck at 0, stuck at 1 at all the input output lines. So if any of the input is 1, the output has to be 1. So I can say equivalence between this and this, and so again 2 or 3 faults, they come out to be same. So now we talk about your this. So in case of the NOT gate, if input is stuck at 0, the output is going to be, so they are equivalent. So I can consider only 1. So as such 2 faults बनते हैं, पर हम इसमें से सिमिलरली अगर इनपुट पे 1 है तो आउटपुट 0 ही होगी, तो ये भी इक्विवेलेंट है. सो 4 में से व्हाट आई हैव टू कंसीडर इज ओनली 2. सो 2 आर एसेंशियल. देन वी टॉक अबाउट NAND gate. NAND गेट पे कोई भी इनपुट 0 होगी तो आउटपुट आपकी 1 हो जाएगी. So again, essential faults, they can be reduced to 4. And last we talk about your NOR gate. I'm doing this, I hope you're clear on this now. So इस केस में आपकी कोई भी इनपुट अगर 1 है तो आउटपुट इज गोइंग टू बी 0. So of these 3, I have to consider any one. So again, Essential is 4. So are we clear what we mean by equivalence? I hope we are clear on that. That is important. Okay. Now with this, we move to the circuit for which we have to analyze. So I actually have to remove this. Consider this circuit. In this circuit, you have to find out what is the number of nodes, what are the number of faults, and how many are the collapsed faults. So you can try it at your end before we discuss. So if we talk about the number of nodes, we have 3 primary inputs. We have this primary output and these 2 intermediates. So they give me 6 nodes. So number n is coming out to be 6. K always remains 2 in our case. So total number of faults which we get is K into n, which comes out to be 12. Okay. Now the important question is number of collapsed faults. Okay. अब number of collapsed faults अगर हम देखें, so let's see how we do it. So I can list out all the faults. So these are the all possible 12 faults. Okay. So how we are achieving this equivalence? Try to do it. I'll do it side by side. You people should also be doing this. So this is AND gate. So AND gate may we know that these are equivalent. I'll take a different color. Okay. So what I'm just going to cross with red what is being reduced. So that makes it clearer. So this is crossed, this is crossed. I am left with these are the inputs. Coming to this, I have to consider any one. So I remove both of these. Okay, I consider only this. Stuck at one. दोनों में से कोई भी consider करना आपको. जो आपका ये जो OR gate है, OR gate में reduction is I have to retain SA1 at the any one of the inputs. So I retain this. This is already cut and this is already cut. So what I am left with is 1, 2, 3, 4, 5, 6, and 7. There is some more reduction I miss. So like this. मैंने 12 से प्ले बनते हैं. अच्छा ठीक है, इसमें ये भी मिस हो जाएगा ना, ये इसके इक्विवेलेंट है तो ये भी गया दोबारा. तो वी आर गोइंग टू अचीव 1, 2, 3, 4, 5, 6. So it means collapsed faults, they are coming out to be 6. Okay. So this is how we have to find out the collapsed fault. This is what we do it by inspection. And what is the purpose of this? This we'll see further. I hope we are clear on this. Everybody is clear on this. How did we do it? Because this is one of the important questions potential questions you are going to expect in your exams. So the answer here is 6. Moving to the next. Okay, I have shared this table for this circuit. This is what I have done it with the hand. Basically, it shows me what collapsing is and what is the whole purpose. Here, actually, I have written all the possible in combination vectors. मतलब हम structural और functional testing का फर्क समझ रहे हैं यहाँ पे. So, what is the purpose of? We have already talked about difference between what is your functional testing and what is your structural testing. Okay. Now the typical requirement for ensuring the reliability and removing that all the faults which are there, we require that we had 6 nodes. We had 6 nodes in a circuit, which gave me 12 possible stuck-at fault models. Okay, faults or fault models. Now I apply the test vectors. जितने भी टेस्ट वेक्टर्स हैं possible, number of primary inputs क्या है हमारी 3 in this case, because what my circuit is, if you have forgotten, this is our circuit, what we were talking about. We are talking about this circuit. Let's number all the inputs, nodes matlab. So these are the nodes. So my primary inputs are 3. With 3 inputs, I have 8 possible vectors which can be applied, and we can observe the output and see if output is faulty or not. जो typical testing principle है, आप vector apply करते हो, output generate होती है, output को compare करते हो, and we see that whether we have any fault or not, and then we are able to detect the fault. Now, when we do this, it is called my functional testing, which is actually exhaustive in nature. It is exhaustive because we have the large number of input space in which we have to apply the testing, and then we have to see what is the output. Okay, but it is possible because my circuit is having only 3 inputs. Okay, and if I assume that 1 nanosecond is taken, so applying 8 vectors and getting the simulation done in 1, it will take me 8 nanoseconds. Fair enough. But what about if I have 64 input circuit? For the 64 input circuit, I don't even know how to compute this number. It would be a very large value. And you can see, if I multiply it by 1 nanosecond, what would be the order of the time for testing? So this is only one part of the circuit, one small part of your bigger complex circuit which you are going to test. So my functional testing, it has its limitation. To remove that limitation, we go for trying to reduce our fault models, in which first step is this fault collapsing by fault equivalence. जो हम कर रहे हैं वो हम कैसे कर रहे हैं ये देखिए हम इसमें लाइक हमने what I have done is मेरे सारे 8 possible combinations लिस्ट कर लिए और एज्यूम किया कि यहाँ पे stuck at 1 मॉडल है, मतलब यहाँ पे stuck at 1 फॉल्ट है एट द नोड 1. सो अगर नोड 1 पे stuck at 1 फॉल्ट है, अगर मैं 0 0 अप्लाई कर रही हूँ तो मेरी आउटपुट क्या आएगी 0 0 0. if it is there, this is 0, this is 1, so one input is coming to the OR gate as 1, so it means output is going to be 1, which is fine. अगर यहाँ पे stuck at 1 नहीं होता तो भी आउटपुट 1 आती, मतलब मेरी आउटपुट डिटेक्ट नहीं हो रही है 0 0, मतलब मेरा ये फॉल्ट, सॉरी नॉट आउटपुट, my fault is not getting detected by my stuck-it fault at this point. Node 1 will not be detected if I apply the vector 0 0. मतलब ये फॉल्ट कोई डिटेक्ट, ये वाला फॉल्ट डिटेक्ट नहीं हो रहा है 0 0 से, आउटपुट सेम रह रही है. Likewise, if I apply 0 0 1, it is going to be 0. यहाँ पे भी डिटेक्ट नहीं हो रही है. पर अगर मैं 0 1 1 वेक्टर अप्लाई करती हूँ तो मेरी एरर इन द आउटपुट आती है. इसका मतलब stuck at one fault at node 1 can be detected by only a single vector. I need not apply all the 8 vectors for each fault model. ठीक है, तो मतलब मुझे एक ही वेक्टर है जो आइडेंटिफाई किया है. Similarly, stuck at 0 at point 1, only this combination, all ones will give me the error in the output. So only one input vector is fine. अब ये जो रेड एरो से मैंने मार्क किया है, whatever is being grouped by these red arrows, they are showing me examples of collapsed faults, what we were doing by inspection just now. So ये जब हम 0 1 1 इनपुट अप्लाई करते हैं तो इन सब में एरर डिटेक्ट होता है, तो ये भी आएगी इस पे कोलैप्स में. इट मींस with 0 1 1 I will be able to detect 3 faults, 4 rather. So what are those 4 faults? It is this, that is stuck at 1 at node 1. The second one is stuck at 0 at node 3. Next is stuck at 1 at node 5. And then we have here this also. मतलब जो सेम इनपुट अप्लाई करने पे सेम आउटपुट आपकी दे रहे हैं वो ये भी होगा. दिस विल ऑल्सो बी इंक्लूडेड. 0 वाला नहीं इंक्लूड होगा आपका, ये वंस वाले होंगे. मतलब सेम आउटपुट एरर डिटेक्ट कर रहे हैं for the same input vector which is applied. So I can see that one vector can detect 5 different faults. Similarly, these two are grouped together. If I apply 1 0 0, I can detect these 3 faults. Okay, so these will be equivalent fault. Similarly, here I can have the equivalent fault. So equivalent faults find out करने से मुझे क्या help मिलती है? I am able to get the minimum set of fault models for which I want to test. And further, this will help me identify the minimum set of vectors which are required to test or find the faults. Okay. In our case, what are the minimum set of vectors which is required to detect our faults? देखो आप इसमें से मिनिमम क्या है. ट्राई टू टेल मी, ट्राई टू फिगर आउट. आई हैव डन दिस वर्क फॉर यू. ये किसी बुक में नहीं दिया हुआ आपको इतना एग्जॉस्टिव एग्जांपल. दिस इज ओनली फॉर योर अंडरस्टैंडिंग. सो इफ आई एग्जामिन केयरफुली फ्रॉम दिस टेबल, आई फाइंड आउट दैट वेक्टर 0 0 1 0 1 0, you can examine from this and then see. Then 0 1 1, 1 0 1 and 1 1. तो ये मिनिमम मेरे 5 टेस्ट वेक्टर्स हैं which are required to test all by collapsed fault models. मतलब जो मेरा reduced set of fault models रह जाता है उसको टेस्ट करने के लिए मुझे पूरे 8 वेक्टर्स को रन करने की जरूरत नहीं है, but I can do with only this 5 subset of vectors. And how did I come to this? Because I saw where is the equivalence achieved, and that equivalence is achieved by seeing that what is the connection, मतलब कौन इनपुट पे कौन सा फॉल्ट किस आउटपुट से कोलैप्स हो रहा है. So I am basically studying or analyzing the structure to find the equivalent faults, which helps me further identify the reduced set of vectors. So when I am exploiting the structure to identify the minimum set of vectors in my circuit, which will give me 100% fault coverage with a reduced set of fault models and a reduced set of input vectors which need to be applied accordingly. That is what is called your structural testing. So basically purpose kya hai iska? We are trying to reduce our simulation time which is used for applying the test vectors and simulating the circuit and identifying the faults. First, we have reduced the fault models, and second, we have further identified जो मतलब a reduced set of vectors which need to be applied for that smaller subgroup of fault models. Are we clear on this or not? Say yes, no, something.
Yes, ma'am.
Okay. So now we move to next circuit. तो ये मैंने आपको दिखाई दिया. सो ओके, ये वही सर्किट है. सो अब हर बार हम लोग मतलब ये करेंगे तो बड़ा डिफिकल्ट है. अभी तो मैंने आपको एग्जामिन करके बता दिया, बट अदरवाइज इट इज वेरी वेरी डिफिकल्ट दैट वी आर गोइंग टू डू दिस. मतलब हम हर सर्किट के अंदर वी कैन नॉट गो एंड एग्जामिनिंग टू सी दैट व्हाट इज द नंबर ऑफ फॉल्ट्स. सो फॉर दिस ओके, ये तो सिर्फ we have already done it. So this shows me what are the equivalent faults. Okay. So there is a formula which has been made which tells me how to get the number of collapsed faults. Okay. So what is this formula? This formula says twice the number of primary outputs plus the fan out stems. A fan out stem का मतलब क्या है? प्राइमरी आउटपुट आप समझते हो. Primary outputs you understand. I will take any one random circuit. Okay. So in this case, what is the number of primary inputs? 2. Primary output is 1. That is why. So this is your primary output. And what is the fan out stem? This is your fan out stem when you have the branches coming out of a single point. Now, why this is important? Fan out is important because जब भी fan out आता है तो मेरी reduction possible नहीं होती. मतलब अगर मेरे यहाँ पे पॉइंट बी पे दो पॉसिबल फॉल्ट्स है, स्टक एट 0 और स्टक एट 1, तो इसका मतलब है कि मुझे ये जो उसकी दो ब्रांचेस हैं, लेट दिस बी लाइन 1 एंड दिस बी लाइन 2. सो मुझे लाइन 1 पे भी स्टक एट 1 कंसिडर करना, दोनों फॉल्ट्स कंसिडर करने पड़ेंगे, और लाइन 2 पे भी दोनों फॉल्ट्स कंसिडर करने पड़ेंगे सेपरेटली. ओके, सो आई हैव टू कंसिडर the faults on the branching on the branches which are stemming out of a common point individually. So that is why your fan out is important. So this is your fan out when we are having the multiple branches coming out from a single stem. And when you are having your multiple inputs coming and this may be going ahead in a circuit, this is fan in. जब वो एक point पे together they are coming and culminating to form a single input, it is your fan in. And this is your example of fan out. I hope I make sense out of this. Okay. So 2 into the number of primary outputs plus the fan out stems, okay, plus total number of gate inputs. जितने भी gates है, intermediate level पे भी जितने भी gates है, सबकी inputs plus the minus the total number of gate inverters. That is what is going to give your, ये plus नहीं आना चाहिए, ये remove करो यहाँ से. Just don't do it. Minus total number of inverters which are there in your circuit. That is what is going to give you the number of collapsed faults. And what is going to be the number of remaining faults? That is your actually essential faults which need to be tested. So let's, अब हम वही ये फॉर्मूला लगा के देखते हैं उसी सर्किट पे and we'll see that if we are achieving the same results. So this was my circuit, what I had just tested. Sorry. And it is the output Y. So number of nodes is now I apply the formula 2 into number of primary outputs. How many outputs are there? It's only one. Plus fan out stem. This is a fan out free circuit. So I have no fan out stem. I put it as 0. Then I add my number of gate inputs. I start from the input level. I start traversing my circuit from the input. So input 1, input 2 to this gate 1, this input to this gate 2, these two inputs to gate 3. So 1, 2, 3, 4, 5. I have 5 gate inputs. And how many inverters do I have in my circuit? I have one inverter. So I subtract 1. So what do I get? You can just compute. This is going to come out to be 2 only. 2 plus 5 minus 1, which gives me 6, which is exactly what we had achieved. Okay. So this gives me collapsed faults. So what are the faults which are remaining? So what are the remaining or the essential faults, I should say, after collapsing will be total number of faults. इसको separate कर लें ऐसे. Minus collapsed or the reduced faults. So that is 12 minus 6 is equal to 6. Okay. So this is important because this is going to be used as an important parameter for my circuit. That is called my collapsing ratio. Okay. So in this case, so we'll see further also. So this is an important parameter, which is set of collapsed faults. Okay, divided by total number of faults. So this is how we actually measure that how much of equivalence we need to achieve in a circuit. Let's examine one or two circuits further so that we understand it better. So ये circuit आप खुद से करोगे. First find out what is the number of faults and then try to see what are the collapsed faults by equivalence. Chalo, I'll start doing it side by side, otherwise we'll not be able to complete. So I start identifying so I have 8 inputs, primary inputs, 1 primary output, 9, 10, 11, 12, 13, 14, and 15. So what is my value of n? N is coming out to be 15, which means my number of faults will be 15 into 2, that is 30. Okay. Now if I apply my formula to find the number of collapsed faults, please mute yourself, whosoever is there. Piyush, please mute your mic, please. If you want to ask there is any doubt, you want to ask any question, you are welcome, but unnecessarily don't do that. So isme, what is the number of primary outputs?
1.
So what is your number of fan out stems? 0.
0.
Hanji. And then we have your gate inputs. Tell me how many gate inputs are there?
14.
14.
Yes, it is 14. And number of inverters is 0. Yes. So this comes out to be 2 plus 14, which gives me 16. So my collapsing ratio will be okay, whatever value it comes, you can just compute. Now, one question I have for you is, should this collapsing ratio be large or should it be small? If you are having 2 circuits for achieving the similar kind of function, uska logic we can expect that we are able to achieve a functionality similar in nature. What should we prefer? Should we prefer a circuit with large collapsing ratio or with a small collapsing ratio? चलो ये तुम सोचना फिर मुझे नेक्स्ट पे बताना with logic. Okay. By inspection, if I try to do this, how will we do it? I'll do it because this can be one probable question जो आपको पता होना चाहिए. Actually, fault dominance को understand करने के लिए आपको जरूरत पड़ेगी. That is why we are doing it. Now on तुम्हारा सारा सब्जेक्ट ऐसे ही करने वाला ही है, examining the circuits. अब theory part has reduced in this. There may be associated theory, but more or less it will be more of doing it yourself. This is from Bushnell. These examples are from Bushnell. पहला circuit Bushnell का नहीं है, पर ये Bushnell का ही typical examples है. Stuck at 0, stuck at 1. You tell me by inspection, are you able to get it? So we are, oh, sorry. So AND gate, oh, It is an AND gate. So this and this. So I can cross any two. Similarly, sorry, I cross this. Sorry, ये SA1 नहीं, SA0 क्रॉस होगा. ये retain कर लिया. मैंने randomly, I'm just doing it. So I am left with stuck at 1. मतलब मैंने सबको आप कह सकते हो कि मेरे सारे इनपुट्स पे स्टक एट 0 हटा दिया. तो मेरी 8 इनपुट्स थी. 8 into 2 16 फॉल्ट्स तो मेरे यही बन रहे थे. और 16 में से 8 रह गए. स्टक एट 0 सबके रिमूव हो गए बिकॉज सारे एंड गेट्स है. तो आई गेट 8 इक्विवेलेंट फॉल्ट्स एट फर्स्ट लेवल. ओके, नेक्स्ट वी गो टू द next level, that is मैं इनपुट्स पे हटा रही हूँ एक्चुअली इसको to make the things easier. Now we go to the next level, that is this, which are going as inputs to the AND gate. अब inputs to the AND gate पे if we see OR gates, what we see is we can achieve equivalence between SA1. हमें पता है OR गेट में किस पे इक्विवेलेंस होती है, SA1. कोई एक इनपुट 1 है तो मैं 4 इनपुट्स है सब में SA1 को रिमूव कर दे रही हूँ. तो 4 इनपुट्स थी, 4 into 2 हमारे 8 थे. 8 में से 4 रिड्यूस हो गए तो 4 इक्विवेलेंट फॉल्ट्स मेरे यहाँ पे बन गए. अब जो रिमेनिंग फॉल्ट्स रह गए अब कह लो. Then we come to the next level, that is this. Again this is for AND gate. AND gate के लिए again I achieve by removing the stuck at 0. मैं इसके inputs पे reduce कर रही हूँ so that it remains. So I am remaining with 2 equivalent faults. So and 2 at the output. So what I get is 8 plus 4 plus 2. That gives me 14. 14 plus 2, that is 16. So I am matching the number which I have got by this formula. So by inspection also and by formula also, I am able to get this result. I hope we are clear on this. Then we'll move to our next example. ये तो वही सेम सर्किट की इक्विवेलेंस है. Now we'll consider a circuit. Okay, ये भी हम कर चुके हैं. अच्छा, एक सर्किट और आपको. हाँ जी.
I have a small doubt. Like in the last example, we took 16. Like, is the 16 number of collapsing faults or the remaining faults?